Hello, my friends of Hatari Labs. My name is Saul Montoya. Please welcome to this tutorial, and we are going to do a simple but very effective parameter optimization simulation for a Basin model with HEC HMS. Okay, so we have done on the description of this video, you will see that we have done a video before, and the video before is actually for the model construction, and this is the model that we are going to open. So in the description of this video, you will find the files required for this model. So here I'm going to HEC HMS. Yep, this is HEC HMS, and I'm going to open this. So please, please locate the files that you will receive here. So on your documents, make a HEC HMS tutorials, and here put ejemplo en gas cancha, and this is where you're going to drop the files. Okay, if you have done this way, so you just have to go file, open, here you say browse. I pressed the wrong button. Let's wait. So HEC HMS, okay, I can open again, I think. Okay. Cool, better I open another one. Okay, here I say file, open, and here browse, and here HEC HMS tutorials, ejemplo en Ascancha, ejemplo de Cuenca, and we open the HEC HMS file. So we go to select, cool, and then here I have my Basin. That's great. And what we are going to do is what we are going to do is we are going to go to components. We are going to add a time series data manager, and here instead of a precipitation gauge, we are going to set a discharge gauge, and the discharge gauge will be new a 401. Cool, that's great. So we have a discharge gauge that will be on our time series data discharge gauge, and this will be here, this one. So, and what we are going to insert, manual entry cubic meters per second every hour. Okay, that's great. On the this, and here for the 1st of January at 00 hour, 00 to the 1st of January of 2000 at 20 hours. Cool. Great. So, and then you are going to, on the files that we have, that we gave you, there is datos de aforo. So we open this Excel file, and on datos de aforo, we have all of these. These are actually observed flows. So they're only 20. So not much to. Okay, so we go to table, and then we paste Control V the values here, and then we have those are the observed values. Cool, nothing hard. Okay, great. And then we go to then we go to point B, and on point B we go to options, and then observe flow here is a 401, because actually you are saying that this discharge value correspond to this point. Yeah. Cool. So then we can save our project here. We can compute again. Okay, We can compute, that's great. And then on the results, here on the results of the point B, you can see which are the observed values, and these are the observed values, the black line, while the blue line is the simulated value. So actually, we have to adjust our parameters in order that the simulated fit the observed values. Okay. What are we going to do? We are going to on compute, create optimization trial, and then we create a new trial, from Cuenca. And where are the values that are going to fit on point B? We are going to use the meteorologic model 1 and say, okay. Okay, ready. And then we go to compute, and here we have our trial. That's great. So it's Cuenca, is meteorological model 1, and this is the 1st of January, and this is, as I say in the previous, this is strictly related to your format, I mean, this is strictly related about how you have your data format. Okay, so please keep in that, because if you are doing January, so it will be with January. If it's in French, it will be in French. And so this is related to Windows, in fact. So here on trial, this will be the 1st of January to the 1st of January. This will be from 0, 0, 0 to 20, 0, 0. And this will be every hour. Okay. Cool. So we are going to make a trial based on this whole simulation period. Okay, and this, we are going on the trial, we are going to add a parameter, because actually what we are going to optimize. So we create a parameter, and then we can create one. We are going to do one parameter, and then we are going to do 3 parameters. So for example, here on the Cuenca Alta, this is where there is more precipitation, we can optimize the curve number. Cool. Yep. And then let's see, I mean, please remember this, and then we are going to okay, we are going to trial, and then we are going to compute. And this is a trial, I mean, this is right, there are several runs where the objective function has to decrease all, and then it gives you an optimization. So in results, not of the simulation, the trial, yeah, you have that the value of the CN number was 55, and the optimized value was 57. Let's see the objective function. It says that it has decreased. I mean, as long as it decreased this value, it will say that it has final optimization. It has decreased from 65 to 57. Well, it has improved, but not so much. So, and then if we go to the point B on the graph, okay, we see that there is something, but it's not so much. I mean, you don't find this like really, you don't find this as like you have done it a match that you don't have better simulation. So we're going to add 3 parameters. So here we put add parameter, and on the add parameter, we're going to specify the Cuenca Baja and the curve number. Yep. And then once again, add another parameter, and here we are going to have on tramo 1 and here we are have, this is the lag time. This is the lag time of the river. No, we are no from, let's say that Cuenca Alta, we are going to the unit in the graph, the lag time. Okay, cool. And then another parameter, compute. Well, let's say, okay, cool. Please remember this, and then if I go to results, I go to the optimized parameters. Okay, let's go to the objective function. It has to increase to 55, and still, okay, I'm going to add a last parameter, that is the lag time of the masking gun. Okay, so here I add a parameter. On this parameter, it will be of the tramo 1, and here it will be the x, that is the lag time. Yep, and then here I run my file, and then here I go to my objective function. Okay, no, I haven't improved my results, but let's see. Okay, what do I have here? Okay, on the graph, well, on the optimized parameter, nope, no. Okay, and this is the optimized. Cool, it seems fine, but not so much. What will I do is I will try optimizing another parameters in order to have a better match. Yep, okay. But this is mostly the procedure. Okay, my name is Saul Montoya. I am from Hatari Labs. Hatari Labs is a website dedicated of knowledge sharing or open source software. Okay. Knowledge sharing on open source software in water resources. We have a lot of tutorials. We are going to do more tutorials on HEC HMS as well. And we have some webinars, coming webinars, and then you can sign up for a newsletter that we have. Please drop your email, and then you will have our newsletter. This is our domain, hatarilabs.com. You can follow us by our Facebook and our Twitter. Okay, our main intention is to provide you helpful tutorials that you can deal with different software, open source software in water resources. Okay, that's our main purpose. My name is Saul Montoya from Hatari Labs. I'm really happy to have brought you this tutorial, and I hope to see you in coming tutorials. Okay, so if you want to give us some words, please through this, and then we read it, and then we can answer. Actually, we don't do homeworks, but we might give you an advice, or like you can give us some ideas for coming tutorials. Okay, guys, that's great. So I hope to see you in another tutorial. Bye-bye.